So there are various encoding methods over here, which can be a non-return to zero, in which it is a method of encoding where the signal remains at the binary level assigned to it for the entire bit duration. Like for 1 it will be a mark level, and for 0 it will be a space level. In return to zero, the encoding the voltage level assigned to a binary 1 level returns to 0 during the bit duration. So whenever we have to communicate 1 bit, then half of the bit time it will be 1 level, which is a mark level, and the half of the bit duration time it will be a 0 level, space level. And we can also have Manchester coding, which is also called as biphase coding, and which is widely used in LANs nowadays. And over here the binary one is transmitted first as a positive pulse for one half of the bit duration, and then a negative pulse for the remaining part of the bit interval. So uh, now we will be focusing on the next slide. There is a terminology which is called transmission efficiency, and which is relevant towards the accuracy and the speed of the information. And we can have a voice information, we can have a video information, we can have analog and digital information which are communicated from the transmitter and the receiver. And the transmission efficiency reflects the accuracy and speed of this data which is being sent from the transmission side to the reception side, and it is a kind of category of the subject which is named as information theory. We have in order to detect the capacity of the channel, uh, how can we detect it? We have Shannon-Hartley law, which is telling us about how much information can be sent over a communication medium, and it is basically based on the bandwidth of the communication channel as well as on the duration of the transmission. And we can have two kinds of channels, which can be a noiseless channel where the bandwidth multiplied by 2 gives us the capacity of the channel, and we can have the noisy channels where we have the signal to noise ratio plus 1 multiplied by the bandwidth log base 2, and this is a kind of a relation. We have b log base 2, in between we have 1 plus signal to noise ratio. This calculation will give us the capacity of the channel in noisy channel conditions. And greater the number of bits transmitted in a given time, the greater the amount of information that is conveyed, the higher the bit rate, the wider the bandwidth and needed to pass the signal with minimum distortion. And but we can also use a narrow bandwidth over here, but for that narrow bandwidth we have to send a data for a large duration, but for a wider bandwidth we can send a data for a small duration, and we can transfer high data rate over here. And we can also see the impact of the noise on the channel, and we can see over here that by increasing the bandwidth, the rate of transmission, which is the rate of transmission, we can have more noise. So we have in typical communication channels, we limit the capacity of the channel to 1/3 to 1/2 the minimum to ensure more reliable transmission in the presence of the noise. Thank you very much.